questions, doubts, consultations, comments regarding clean application energy applied to mining, please raise your hand. I think there's no question. Thank you very much. We continue then with our next presentation related to the high-pressure grinding rolls, the greatest in the world, by Patricio Mujica, manager of Capital Metso Chile Equipment, and also Mauricio Gomez, manager of great drivers in Chile. Good afternoon. I'm among many electric engineers, but I decided to work on processes. But I'm also an electric engineer. And today, there's an issue that's quite important because technological changes there. We will see the development of HPGR development very briefly, and the history of HRC, the design concepts and advantages. The line of products very briefly, and we will present the greatest HPGR in the world, the biggest, and its results in a concentrator that is Morenci Metcaft flip board that has been operating 2.5 years without any replacement of parts. We say this is the next generation of HPGR, which originates in limestone and cement industries. And HRC was requested by our customer in order to be able to advance to progress in the general concept of HPGR and solve the problems they particularly had, because they have facilities in Cerro Verde, they have HPGR there, and they wanted to see if Metso was able to develop an equipment for mining. What is an HPGR? Really, these are two wheels that have inverse rotation. One is fixed, the other mobile. Hydraulic cylinders press the floating wheel, which leaves a gap in a zone where we call crushing zone. There's a crushing between particles, and this is what changing the path of future projects. The harder the mineral, the better this technology works. And we know that all mines today, first, have low grades, and secondly, are going to primary minerals that are very hard. So this represents an opportunity. But the other problem of mining of this kind is that since the grade is so low, they need to treat high tonnages of mineral. And up to now, there's no equipment with the necessary tonnage, and a tonnage that would allow managing this kind of or tonnage. Advantages: they have a low operation cost, energy efficiency, we will demonstrate it, and they don't require milling. There's a micro fracturing of particles that prepares them for the next phase where less energy is used. And there's an improved recovery, therefore, in flotation areas. What can we do to select HPGR technology. The competence of the mineral should be high. That is, it should be quite hard. And energy costs should be high. In Chile, the energy has a high cost. And the milling costs are the balls usually, but also the lining of the mills. And they also require high production and the mine to have a large life. Crushers can be used as tertiary, followed by ball mills or vertical mills. A quaternary crusher followed by a vertimill or ball mill, and the pebble crusher in SBAC circuits. Applications usual are iron, diamond, platinum, copper, and so on. In 6 years, we developed this design, and therefore there are equipment that were used together with the client's equipment, mechanical mining, and also materials part and hydraulic sciences used here. And we had to start developing special simulation models. Innovations. The key innovations in this HRC, that is hydraulic roller crusher, means that's the meaning. Requires that we maintain parallel rollers. This is a great effect that this is what caused many plants to be stopped in original HPGRs. So when we feed this machine, conventional HPGRs are damaged with the segregation of material because the pressures of rollers is different. And additionally, flanges were installed on the rollers, flanges. So what cannot be done in others, because they had one that was floating, but here we make the rollers to be parallel because they have a framework, or a frame really. Also, the strength of crushing was applied somewhere else, not parallelly or horizontally to the floor, but it was applied in what I call nutcracker in the upper part. This is what usually happens in a traditional HP. As you can see there, where pressure is applied, when segregated material comes in, is fed, this deviates because the rollers are not able to quickly do what they have to do. But here we developed a closure for bearings and rollers within a frame presented there. This is a frame, the design with a torsion tube, and it's pivoting at the base. Therefore, in the upper part where you see that tab, below we have the pivot, and up there we have the closure system, so hydraulic closure. Which are the advantages? It eliminates stopping of the machine associated to de-alignment of the wheel rims. It prevents damage in the bearings due to de-alineation. It simplifies the design of the machine and does not require lateral plates and uses flanges. Since it does not deviate, the rollers are parallel, we could place the flanges. And then we realized that had a very interesting effect, the flanges. Here we see the rim effect in a crushing condition that is not as efficient as it is in the rims because material drops off. So it's less efficient at the rims. So we placed a cheese plate, and there that's a conventional HPGR. And what we see there at the curve, the pressure on the roller. The higher pressure should be in the middle, in the center, and lower towards the side. Here we have a comparison. There's a high wear out at the rims or borders. That's what is called the border effect in the standard model. We have a lateral view there. In the case of the HRC, since it has flanges, the material is confined, and it moves with that together with the flange, so there's almost no wear out. In this case of HPGR, the conventional one, there is a difference in the velocity of the wheel rim, or the teeth plate and tick plate, and the material. This is, we put the string gauge on the roller and we measured there without the flange and with the flange. As you can see, the pressure shown is quite more uniform when the flange is on. Here we have a decrease of the rim effect due to design. We have the specific force we applied. The one test with tick plate and the other with flange. We applied 4.49 on the tick plate and 451 on the flanges, so the change was 0.3%. The tire speed of the roller really decreased also. Tonnage increased by 21%. This because in having a better crushing zone, particles are finer, and therefore recirculation is lower, and more feed is taken in. Tonnage, dry tonnage increased from 57 and 61 to 61. It increased by 7.9%, and the specific throughput increased 11%. Also, we can see what I mentioned already. There's a decrease of F80, and the product also, there's less, it decreases when we use flanges.
We will skip some of these things because I would say that they are not as important. Let's go to the product line that we had from before. And this is a little bit the comparison we had, and it's going to be taken for with the size. I was in Morenci, and it's really shocking. It's massive. This is what we call the arch, and we make this to be always parallel. And up there is where we have all the pivoting. So it's kind of a balancing we get. We leverage it because we are using this type of effect, this leveraging effect. Now, we have from the HRC 800, which is the one that we are currently using in pilot plants, and we are currently installing one in Centinela Mining Company. Hopefully this will be commissioned next week. And also the HRC that has a diameter of this roll of 3 meters. Metcaft is from Freeport-McMoRan. It's in Arizona. The flow chart was based on the experience that we had in Peru, Cerro Verde, also Freeport, and it was commissioned in the year 2014. The concentrator is designed originally for 63,500 tons of copper up and downstream. But today, we cannot do it anymore, but we are past almost 90,000 tons. Mauricio, please, the electrical part is all yours. Okay, this extraordinary collaboration that we had with Metso to try to reach the size that we needed because of the capability that Patricio mentioned. The technology we have in order to get the control of each one of those press or rolls in each one of them is the frequency variators. So one of the most meaningful patterns was because of the great power that it means to drive these rollers, and also according to what our colleague mentioned of the quality, the harmonics that we needed for this type of applications was quite meaningful. And then that's why we got a line that is called Perfect Harmony, that is water refrigerated, and that has the capability of including 30 pulses in the rectifying stage, so that from the quality point of view of the energy, there's no contamination. So that's one of the aspects, no noise, that's one of the aspects where the project was built on. The second aspect is in the way in which this is driven towards this driving, so as to know that what we were using. And when using this technology, we have 11 levels in the inverso, which means that I can have waves without any use, and that means that I will be able to have standard isolation without any rollings on the side, which means that there is an implementation that is easier. So from the quality of energy, input and output, this is solved through multi-cell with 30 pulses that connects in 13.8 and in 6.6 output to the engine with a sinusoidal type of characteristics. This is quite analogous to our own number of cells. It also has the possibility, even in the contingency in semiconductors, to be able to bypass some of these power cells and rebalance the electric neutral so as to continue in this workaround, even in semiconductor. That's a patent we have developed that is called Protos, and as part of this technology. The single lineal is connected in 13.8 and 16.1 kilowatts each. Look at the size of this application. We're talking about more than 11 megawatts, and that's why we need the harmonics and why this was so meaningful in the application. And also the usage of the areas around this isolation, which means in longer terms, in the long run, that we need to buy a new machine because we're talking about standards and in powerful areas. Now, control could be implemented in the CPUs of our frequency variables or variators, which means that there is not an automated system needed that is ancillary to our drive, but this control system is in the CPU of our system. What is it about? This is a loop in terms of speed cascading to the torque one, so that the reference that is needed by the master variator to the other variator is key, because it's sent by the press, is a torque control. So if we lose this synchronic, the speed will be sent to the slave so that it could go back to this same control mode. This is a loop system, and this helped us to get the synchronic mode of this equipment, which is basic for this type of technology. No tenemos audio en cabina. No audio. These are the results in the availability, because it's not only, of course, good things we have to share, but things or things where you had issues as well. We had some issues with the bearings. We had to change them, and there was, of course, an issue there. Another one is a shutdown, general shutdown, and then we had to go through an issue for one set of those rollers, which is, I would say, because there was noise or contamination, because the dust extraction in the equipment was only on one side of it. Then we had this kind of curtain, and then it was not taken from the other side, and that's the one that did not work. Today, it's I guess that after 1 year, so since it was the first one, I would say that this was interesting, but we got to the production that we had expected or forecasted. One of the most important things, which is the roller wear, is good enough, because look, it's 15,000 hours of crushing without changing one single thing. This is an HPGR after 8,000 hours. That's what regularly happens. And so you can see the difference. It's key, right? And that's just because of the pressure of how the material is distributed in the same areas, in different areas. We have work progression hours of around 16,000 hours so far. So that means that we have a lot of room yet. The conclusions are, we have developed the HRC by Metso through meaningful improvements, such as, for example, the arch frame design and the installation of these flanges. The new characteristics have shown certain advantages in energy efficiency and the size of the product compared to the conventional HPGR. Freeport-McMoRan installed the largest one around the world in Morenci, and they have acknowledged that it's been successful. Thank you very much.